Hello students, today this lesson 6M6 lessons 6 and 7, the mean. We're going to learn about statistical means and how you calculate them, why they're important, and a little bit, maybe a little bit more, or maybe not much more. So let's cut over to our magic window and get going. So again, lesson 6 and 7, you know, the mean. Okay, the mean is another word for average. You've probably heard about this. You probably have an average. You probably have an average grade in your class. You probably have an average. You've probably heard of a basketball average. A basketball scoring average. And we'll look at an example of that later, how we calculate that. So let's start about with what is a mean. A mean is kind of like, it's kind of a middle. So let's just look at two numbers to start really easy. We're going to look at the mean of 2 and 6. So the way that we think of mean, or the way a lot of people will think of mean, is if you have a 2, 3, 4, 5, 6, 3, 4, 5, 6, and you have the number 6 and you have the number 2, and you're looking for the average, you're looking for the middle point. You're looking for a point that's this kind of the same distance from each one. And so the mean of 2 and 6, we can look at it graphically, and it's a 4. Okay, and it's really a balance point. So if we took the number 2 and 4 and we put them on a balance, and we put a big balance here, like a seesaw, and then we put two people equal weights right here and here, the seesaw would balance because we found the middle point. If we put that middle point on the 5 or on the 3, right, if we put it here, it would not balance, and if we put it over here, it would not balance. We need to find that middle point. And so that's one way of looking at the mean. The mean of 2 and 6 is 4. Okay? But we don't just talk about means of two numbers. We also kind of talk about them as the mean of 3 numbers. So again, we kind of counted 2 this way and we counted 2 this way. So let's think about 1, 2. We're going to think about the mean of some more numbers. 1, 2, and say 1, 2, and 6. 1, 2, 3, 4, 5, 6. And let's just count down. We'll count down over here to 0 and count over here to 7. No one has 7s always do that. So 7. So we're going to look at a balance point, but now we're kind of looking at a middle ground, if you will, of 3 numbers. Well, you don't go halfway between these two numbers, because if we put a balance over here, it would be, this side would weigh too much. So we kind of are looking for like this kind of average, this balanced spot. And the way that we ultimately figure out to do it, it's going to be right about here on the 3. It's going to be here on the 3. And I'll show you why. Because if we take the middle ground and we call it a 3, then we have 3 units. Remember up here we counted 2 units to get to the middle and 2 units to get to the middle. Over here we count 1, 2, 3 to get to the middle. And on this side, that's on the right side. And over here we count 1 for this one, and here we count 2 for this one. So we kind of have a thing that's 1 to the left and one that's 2 to the left. So that's kind of 3 to the left. And over here we have kind of 3 to the right. So this is just a kind of a graphical way of seeing the mean. And so the mean of, so then you'd say that the mean of 1, 2, and 6, if we look at that as a data set, don't worry about these squiggles. The mean of 1, 2, and 6 is equal to 3 because it balances. But that's kind of just the visual way. That doesn't really help me. You know, if I get a lot of numbers, this is going to be a hard thing to do. Find that middle point and sit there counting back and forth. So the way that we calculate mean, there's a numerical way, a numeric calculation for mean. And it's this. You take the sum, the addition, the sum of the data elements, the sum of the elements. What are the elements? The elements are the data set. So here the elements were 2 and 6. And over here, the data elements were 1, 2, and 6. So in the top case, we take the sum of the elements and we divide by the number of elements. So let's give that a try. So in the top case, the sum of the elements is 2 plus 6 over the number of elements. Well, there's 2 elements, so it's 2. So that's equal to 8 over 2, which is 4. And that's where that's our balance point, right? That's what we figured out was the middle number, so that's good. So let's do our second case. We'll do that one in green just because we don't have a green one yet. And we'll say, okay, well, what's the sum of our numbers? Well, the sum of our numbers is 1 plus 2 plus 6 over the number of numbers. Well, in this case, we have 3 numbers, a 1, a 2, and a 6. So the answer is 1 plus 2 plus 6 is 9 divided by 3. So our mean is 3. Which makes sense. That's what we wanted, to get that 3. So that's the balance point, and that's the mean. And that's also called the average. So it's the balance point, and the mean, and the average are all the same thing. All right, let's keep going and let's do a few more calculations on average. Oh, here's what I told you. Wow, this is interesting. But let's ask this question first. This will be part B. Part A will be, I got scores on a test. Well, I got a B on a test and a B on a test, and I got an A on a test. So is my average a B or an A? Well, some might think it might be a B, but let's see if it's an A. Let's do our numerical calculation and see if the average of 88, 88, and 97 is a B or an A. All right, so let's take our sum is 88 plus 88 plus 97. And the number of numbers is 3. There's 3 numbers, 3 elements. So our sum of our elements, if we add them all together, is 273 on our calculator. Let's just make sure. I'm going to type it in one more time. 88 plus 97 is indeed 273, and we'll divide that by 3. Well, 273 divided by 3. We could do it on a calculator, but I'll do it right here, is a 91. So the average, the mean, is a 91. So that you actually are averaging, you got 2 B's and 1 A, but the average is a 91. So you actually are averaging an A, which is kind of cool. Well, let's do one more calculation. So we notice here, this is actually Steph Curry. I took this example off of the web. So Steph Curry in the Rockets, let's just see what was his average in the games they played against the Houston Rockets in the 2019, this is the 2019 playoffs. Let's find his average. We're going to find Steph Curry's average or mean points scored against the Rockets. So let's see. Let's circle the points. So here's points. So let's find his average points in the Rockets series. Well, he scored 33 plus 25 plus 30 plus 17. We're finding the sum plus 20 plus 18. And how many elements, how many data elements are there? The number of elements is 6. So let's see what his average points scored was. 33 plus 25 plus 30 plus, okay, equals 33 plus 25 plus 30 plus 17 plus 20 plus 18 is 143. Divided by 6, he averaged, so his average was 23.8 was the mean. So that was his average, also called in basketball, that's your points per game. So you can do some pretty powerful stuff with means. And what we're going to do now is we're going to switch back over to just looking at me, and I'm going to say goodbye for now. That's means. Next up is a way of finding, we're going to talk about variability of data sets, and I have some good examples of that in the next video. And then we're going to move on to median and box plots. And then that's going to be it for 6M6, just the kind of high-level, fast overview of 6M6.